Alright, for this video, we're going to start Chapter 2, and it's going to take us 2 days to do quadratic functions. We're going to go back to basically 1.5 when we graph parabolas. And the first thing, definition of a quadratic function. This just means that we have an x squared in it, and that's the highest exponent. So we say kind of a definition, we say ax squared plus bx plus c. And then restriction, we say a can't equal 0. Because if it did equal 0, then it would be a linear function, not a quadratic function. Alright, now the form that we want it in, and this is the form that we had it in when we graphed before with the basic shapes with all the translations, is this. We'll say f of x equals a times the quantity of x minus h quantity squared plus k. Now h and k are going to be numbers, and the most important thing, h, k, whatever those numbers are, they're going to be the vertex. H is the horizontal shift, k is the vertical shift. And a, well, what does a tell us? That tells us two things, whether it goes up or down, the parabola, and whether it gets wider or skinnier. So I'll even put here as a little side note, if a is greater than 0, you know the parabola goes up. If a is less than 0, we know the parabola goes down. This is a lot of stuff we did before. The question is, first of all, when we have it in this form, it's very easy. We've done it before. Did it a couple weeks ago. The question is, how do we get it in this form? Now, if you look at number 1, this form that it's in this form, the definition. In order to graph it, and to graph it by hand, I want it in standard form right there. Now, we're going to go back to Algebra 2. It's going to get a little messy, I'll tell you, but we're going to complete the square. Because this right here, x minus h quantity squared, that's a perfect square. So that's the process we're going to do to get it into standard form. Now we can only complete the square if the leading coefficient is 1. And it is in this case. It's 1x squared. So what I'm going to do when I complete the square, I'm just going to say equals x squared plus 6x. And then I'm going to have plus whatever the number is, then minus whatever the number is, then this plus 4 I leave to the side. Alright, now to complete the square, in order to get a perfect square binomial, this is the key term, the coefficient for the x. I take half of that and then I square it. Well, if I take half of 6, I get 3. And when I square 3, I get 9. So I'm going to put plus 9 and then minus 9. And the reason why I do that is because I can't just put plus 9 because that'll change the equation. So then these first 3 terms I group together. And then this is a perfect square trinomial. This factors to x plus 3 quantity squared. This number right here, when you factor it into a perfect square, this is always half of that middle coefficient for x. And then on the outside you have this, the minus 9 plus 4, well that gives us minus 5. Now I have it in standard form. Now it's very easy. The vertex is -3, -5. And I have the a value. This is assumed to be 1. The a value is 1. That's all I need to graph. So I'm going to go to -3, 5. Let's see here. So I go to the left 3. I go down 5. 1, 2, 3, 4, 5. I have that point. Okay, then the a value, this is 1 right here. So that means from the vertex, I go to the right 1 and I go up 1. There's going to be a point there. And then from here, I go to the left 1 and I go up 1 because a is 1. So it's not going to get wider or skinnier. So I have this point and I have this point. And there's my parabola. Oops. Okay? Alright, let's do the second one. Okay, the second one, what we notice is there's a negative in front. So this negative, I have to get rid of that. Remember, I can't complete the square unless the leading coefficient is 1. In this case, it's -1. So I'm going to pull out a negative. And then inside the parentheses, I'm going to put x squared. Then this plus 6x, since I pull out the negative, is going to change to minus 6x. Right? Because I distribute the negative. Negative times -6 is plus 6x. Then I'm going to put parentheses. And this last term, I always kind of leave that on its own. Okay, because that x squared plus 6x minus 8 does not factor. Well, it's the same thing. I'm going to put plus and then minus to compensate. Well, same thing. You take half of 6, it's 3, and you square it. So I'm going to have plus 9 and minus 9. Alright, now the thing that's a little tricky here, since I have this negative, well, let's first group the first three terms together. X squared minus 6x plus 9. Now, this is real key. Since this is minus 9, this is really like you're distributing negative 9 to this. So if I distribute negative times this negative 9, it becomes plus 9. And I put that on the outside. And then I just drop down this minus 8. Alright, you might be saying, well, why do I have a plus 9 here and a plus 9 here? Well, this plus 9, this first plus 9, is really minus 9 because you distribute this negative 9 to it. Alright, then I have the perfect square binomial that factors to x minus 3 quantity squared. This sign right here is always going to be the sign of that first symbol. And then 9 minus 8 here gives me plus 1. So my vertex from this is 3, 1. And my a value is negative 1. So I'm going to put the vertex at 3, 1. So I go to the right 3. I go up 1. There's my vertex. Okay, I'm going to use my arrow. Now a is negative 1. So that means when I go to the right, I'm going to go down 1. So I'm going to have a point there on the x-axis. Then I go to the left 1. I'm going to go down 1. So I'm going to have those two x-intercepts as my next 2 points. So let's say I go to the right 1. I go down 1. There it is. I go to the left 1, I go down 1, there it is. There's my parabola there. Alright, so it might take a little bit of time in getting used to completing the square, but that's the whole key. You take half of this middle term and then you square it. Okay, let's go to the next. Alright, on this next page we can see that for number 3, it's 2x squared. Again, I can't do anything if that's 2. I can't complete the square. I have to pull out a 2, just like I pulled out a negative for the last one. So I pull out a 2. I'm going to have x squared plus. Now, I can't just put 8x, right? 2 times 4 gives me 8x, so I'm going to put plus 4x. Right, then I'm going to put plus, fill in the blank, minus, fill in the blank with that same number, and this plus 7 I put on the outside. Now at this point what you should do is just pause the video. See if you can fill in the blanks. See if you complete the square, go the whole way, get the vertex, figure out what the a value is, and get the graph. So right now pause it and then complete it on your own. Alright, hopefully you've done it right now, and now you can kind of check the work. This right here, our middle coefficient's 4. If I take half of it, I get, what, 2, and then I square it and I get 4. So I'm going to have plus 4 minus 4. So I'm going to have 2, and then I group the first 3 terms together when I complete the square. So it's x squared plus 4x plus 4. Now again, this is where it's a little tricky here. It's minus 4, but I distribute this 2 to it. So 2 times negative 4 is negative 8. So I put that on the outside. And then I just bring down the plus 7. So then, now I have this perfect square. That's going to factor to x. Now remember, since this first sign's a plus, it's going to be plus. It's always half of this, so it's x plus 2 quantity squared. Then negative 8 plus 7, that gives me negative 1. So that works out. So this is it in standard form. So now my vertex is negative 2, negative 1, and my a value is positive 2. So the parabola is going to go up, but it's going to get skinnier now because that's a positive 2. So let's graph this. We're going negative 2, negative 1, which is right here. Okay, I use my arrow. Now, here, when I go to the right one, I'm going to go up 2, 1, 2. So there's a point. So let's say I go to the right one, I go up 2, there's a point, and then I go to the left one, up 2. So that's our parabola. All right. Okay, let's do the last one. The last one is where we don't have a graph. Now, it can really help us if we do graph it. There's kind of 2 ways to do it. A graphical way, which is very good because that's what we've been working with, and then an algebraic way to kind of prove it. All right, so if I do this, if the vertex of a parabola is at 1, 2, and it passes through 0, 0, write the quadratic equation in standard form. Well, again, standard form is this. F of x equals a times the quantity of x minus h squared plus k. Okay, hk, remember, that's the vertex. Well, in this case, 1, 2, that's hk. So I'm going to plug that in right away. I have a, and then I have x minus, h is going to be 1, and k is going to be 2. Right? Shifts to the right one, and it goes up 2. The only thing that I have to find here is this a. Well, let's do it the graphical way, and this might even be even easier for this. I want to make a little, very rough sketch here. And I'm going to graph 1, 2, which is right here. Now this is the vertex. And then it says it passes through the origin. Well, obviously you can tell right away this parabola goes down. Looks something like this. So I know A has to be negative. Well, we could figure it out, right? I'm going to use a little pointer here. This, I go to the left one, and I go down 1, 2. So it's kind of my slope. I go down 2 to the left one. So the A value is going to be negative 2 because I went down 2. So then I could just replace it. Now, if you wanted to see it the algebraic way, all I have to do is I'm going to take this 0, 0. Right, I already figured out this 1, 2, this was HK. This 0, 0, I can plug that in for x and y. So remember, f of x, I'm going to put in y for that. That's the same thing as y. I'm going to plug in 0 for y, so if 0 equals a times the quantity, this x is going to change to 0. And then I have minus 1 quantity squared plus 2. Well, this right here, 0 minus 1 is negative 1. Negative 1 squared is 1. So you get 0 equals 1a plus 2. So if a plus 2 equals 0, a has to equal negative 2. So I did it algebraically. Here, I did it graphically. Regardless, this is our equation in standard form for the quadratic. It's negative 2 times the quantity of x minus 1 squared, and then plus 2. So this, we're able to get the equation based off of it giving us the vertex and a point that the parabola passes through. Okay, when doing this video, definitely the toughest part is completing the square. It can be a little tedious, it can be a little confusing, especially when you pull a negative out, or for I think number 3 you pulled a 2 out. All right, look that over again. Take your time looking over completing the square, because once you get it in this standard form, it's very easy to graph because we've graphed it before.